Hi everyone, so this is our last lesson for our triangles unit, and we're looking at proofs today. Everyone's favorite, I know, but I do like them actually. So let me click over here. So I'm just going to start off with kind of some tips on how to find this stuff, and because I know sometimes that confusing part is how do I get from what they're asking me and how do I set that up. So ways to prove triangles are congruent. Most of the proofs are asking you to prove either an angle is congruent or a triangle is congruent. So I'm going to show you some ways to sort of get started here. So first thing you want to do is, so they're going to give you some info. Of course, you're given information. And then you have to find a few things from there. So you want to, hold on, sorry. Okay. So I'm going to say find any more info you can. Using the angle relationships you've learned. And I'm going to go ahead and write those. I want you to write them as well because I doubt we have them completely memorized yet. If you do, then awesome, but it won't hurt to recap. So the first ones you could use vertical angles. So they're opposite each other and they are always congruent. All right, you could use alternate interior angles. That's on parallel lines, remember? Opposite sides of the transversal, but inside the parallel lines. Those are congruent as well. You could use the sum of interior angles relationship, which means they add to 180 degrees, or all three equal 180 degrees. You could do sum of exterior angles. This one you probably won't use quite as much, those past two, but sometimes they may be able to help you. So that would be, they're the sum of the two opposite interior angles. And again, I'm going to kind of put this in. This one and this one may not be used quite as much, but sometimes you can use those. All right, isosceles angles. So this is, if you have an isosceles triangle, the congruent sides have congruent angles as well. I'm going to say opposite angles, the ones that are the opposite across from them. Okay, and then lastly, equilateral angles. So for an equilateral triangle, all three angles equal 60 degrees. All right, now from there, so once you've found any missing information that might be helpful to you, you want to, so from there, use one of those congruents that we talked about last time. So like side, angle, blah, blah, blah. Okay, so one of the following, and let's recap these. So we have side. And when I say this, remember that that means with the two triangles, they have a side that's congruent, a second side that's congruent, and a third side that's congruent. So all these names are talking about things that are congruent. Angle, side, angle. Also remember they have to be consecutive or in a row. side, angle, angle. Angle, angle, side. And then lastly, hypotenuse, leg. And that is only for 90-degree triangles, or right triangles. Okay. And next thing here, CPCTC. Okay, so what that stands for, what that means, so on your proofs you can write this shortened part, but if you're saying it in class or whatever, I would like you to say the whole thing. So corresponding parts, or if you're just thinking in your head so you know what it means, corresponding parts of congruent triangles are congruent. Okay, so I'll give you an example here. So let's say I have a right triangle, ABC. Okay, I have this leg and hypotenuse. Okay. All right, so maybe that's what they give us, okay? So the congruent statement for this would be triangle ABC is congruent, and I would have to say to triangle NML, because remember I have to match up. So like this side was the one that didn't have the congruence symbol, so that's the one I have to like match up with each other kind of there. All right, the reason for that is hypotenuse leg. All right, now from there, since we already know that those are congruent, so say that's the information they gave us. They gave us that statement and that drawing. Now, using CPCTC, corresponding parts of congruent triangles are congruent. So now I could say, well, angle BCA, this one, is congruent to triangle MNL. So this one, all right, because that's the corresponding part from this triangle to this triangle. Corresponding, remember, means they're in the same location on the opposite drawing or whatever you're looking at, okay? All right, so that's another one that you can use a lot. So let's move on here. Okay, so our first proof here. So R is the midpoint of QT and QS is congruent to ST. So I want you to write this down. Mark this info on the drawing first. So by that I mean like use your symbols that we've learned and mark it. So R is the midpoint of QT. All right, so just gonna write midpoint. Okay, right there. All right, now it says QS is congruent to ST. So I use my congruent symbols. All right, now I'm going on to my proof. So statements on the left side of our column and reasons on the right. Okay, first statement should always be what? Given. And remember, you need to write it out. That one's short enough. So R is, if you just write a squiggle, I will not give you credit because all these are short. So R is the midpoint of segment QT, and segment QS is congruent to segment ST. The reason for that, it's given. Okay, now I'm ready to go on to that first part. So we talked about find any more info you can using your angle relationships. So what we have from here, so I want to look at my triangle. All right, so I thought next, well, from there, if I know that R is the midpoint, well, that means QR is congruent to RT, all right? I know that because it's the midpoint, and I can go ahead and write that now. So QR, that would be my first statement. QR is congruent to segment RT, and we know that because definition of midpoint. All right, so look and see. All right, is that enough to prove congruence of these angles though? So, well, not yet, because first I'm going to prove the triangle is congruent, then I can prove the angles are. So next would be, what else can I show is congruent? Well, the triangles QRS and TRS share this side, so that's their common side, okay? So now I can say that that is congruent. So RS, and I know that one seems obvious, but so RS is congruent to RS because it's on both triangles though, so that's why I need to write it out, okay? Couple ways you could say that. You could say reflexive property, or you could say common side. Either way. All right, now we have enough to prove that the two triangles are congruent because this is side, side, side. We have three sides, okay? So triangle QRS is congruent. Remember, I couldn't start with like S now. I have to start, well, Q is out here, so I'm going to use the one out here. So T would be my first letter. And then, okay, into R, and then S. So this one's pretty easy because they shared R and S. You just need to switch Q and T. So those are congruent, and I can say that because side, side, side congruence. All right. Now we have our very last thing, what we're looking to prove. So they want to know that RQS, so that's this angle, is congruent to RTS, so this angle, all right? That's what we're trying to prove. So from there, the reason I can actually go ahead and say that, because if I know that those two triangles are congruent, then every part of that triangle is congruent from there. Okay, and that is our one that we learned today, the CPCTC. So corresponding parts of congruent triangles are congruent. So if we know the two triangles are congruent, well, this angle is congruent to this angle, this one is congruent to this one, and then of course the main one that we needed. So final would be CPCTC. All right, question 2, or proof 2. So again, start off first, mark the information that they give you here. So mine's not going away. Okay, can't see this very well. I don't know why, but so they said that BD, which is right here, is congruent to DE. So I'm marking those. CD is congruent to DF. So here, nope, just kidding, not there. It's hard not seeing these. Sorry, my recipes are popping up. CD is congruent to DF. All right, there we go. And we're trying to prove that BC is congruent to EF. All right, so set up your columns. Oh, that's real bad. All right, so first thing, can we find anything else now? So find any more info you can using your angle relationships. Well, the one that stood out to me, actually, I would take a pause, but then I'll tell you that. So take a pause here, see what else you can find using your angle relationships that we listed on the previous page. So what can you prove? What else is congruent? Okay, hopefully you've paused and you're checking back in now. And ideally, you found a set of vertical angles, which would be BDC is the vertical angle to EDF, which is here. So vertical angles are congruent. So I know that's going to help me prove that triangle. I do need to write my first statement is my congruent. So BD is congruent to DE, and CD is congruent to DF, and that reason would be given. All right, then I can say angle BDC, so the part I just marked here, is congruent to angle EDF. All right, and for that I would say definition of vertical angles. All right, now I'm looking next. If I'm trying to prove either segments or angles, okay, I want to write up here, prove triangle congruence first, because you have to establish that before you can prove that a segment or an angle is congruent. All right, so do we have enough information right now to prove that triangles are congruent? Yes. I'm going to write the triangle statement. I want you to fill in the reason. So it would be triangle BDC is congruent to triangle. Actually, let's do that. So I want you to fill in what are those three letters, what order they have to go in, and then fill in the reason. So that will be one of your like side, 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 one of your congruents like that. Okay, so take a pause, finish that off. Okay, so you should have gotten BC congruent to EDF, and that was by side, angle, side, congruence. All right, now, anytime we've already proved our triangles are congruent and we are looking to prove this, so we're trying to prove that BC is congruent to EF. Once we already have our triangle congruence established, then any corresponding parts are also congruent. So I can now go to say BC is congruent to EF because corresponding parts of congruent triangles are congruent. CPCTC. All right, that one is done. All right, and last one here. So given NL bisects KNM. So KNM is, just a second here. Oh, goodness. Hold on. Pause. What did I do? Okay, sorry. So we are showing that NK, and this is again not going away. There we go. NKL is that one. So NL bisects, I'm on the wrong one. Just fast forward that. Just pretend I didn't say any of that for a minute, okay? Let's just start over where I can see. All right. NL bisects KNM. So KNM is here. So if that bisects it, we know that this angle is congruent to this one. All right, and it also bisects KLN, so that angle, meaning those two are congruent to each other. This doesn't make this one and this one congruent, okay? It doesn't tell us that, so be careful on that. So I marked my information there. All right, I'm going to set up my table. Okay, and now I need to find any other information that I can find. So take a pause here, look at that, so those set of triangles, and see what else can you see or can you find that is congruent. All right, hopefully you have found something else. What you should have found was simply the common side, so NL there. All right, and actually I didn't write my given, so let's do that real quick, and we'll come back to that. So given was segment NL bisects K and M and angle KLM, and that's given. All right, and I also need to tell you that there was a little typo here. This should say NKL is congruent to triangle NML. All right, so coming back to that common side. So NL is right here. It's a common side because it's shared between both of the triangles, all right? So I know, well, it's the same segment, so it has to be congruent to itself. And when something's congruent to itself, that is the reflexive property, or common side. All right? Now, we're going to look up and see, is what we have here enough to prove that those triangles are congruent? So I will tell you that it is, and all we're proving on this one is the triangle. We don't have to prove a segment or an angle. So I'm going to write that out, but I want you to take a pause and tell me what tells us that. So remember, it's going to be something, something, something congruence. So like side, 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 whatever. So take a pause. Okay, so you should have found angle, side, angle. And that would be your final statement there. And that was enough to prove your congruence and be your final step there. Remember, for a proof, your last line always has to match this. If it does not, you're either not done or you did something wrong, okay? So make sure you're checking back. All right, and that is all for today. Please remember to be checking your homework with the keys, asking Miss Bowles, having it checked to make sure you're doing it correctly.